So how was the the couple of yesterday's session with Victory? I know
Okay,
you
I think.
had a noon meeting with him, right?
Yes, yeah. So
Okay.
I
So how did
think
it go? Yeah.
yes, okay. So I think he's got the concept of the decentralized versus the centralized better now.
Mhm.
And I think the whole concept of the matcher being a third kind of node in the system,
Mhm.
and that any node can publish is perhaps also a bit clearer now. So we'll see what he has this morning. But I basically showed him how I would have done one of the the subscribe message or something like that, and kind of the detail that we are looking for in the algorithm. So let's see what he has this morning. I'm just going to send him a message.
Okay. Okay.
See if he is online. I see. So let's just see if he can join. Um, he's driving on the left or on the right hand side of the car in Taiwan.
Where the left? It's the same as the U.S.
Okay. Okay,
Okay.
cool.
Yeah. Yeah. You guys are on the
Ah,
right, right? On the west.
that's right. Yeah.
Okay.
That's always confusing. Really.
Yeah.
Oh, yes,
Yes, sir.
Victory.
Hi. Hi,
Hello,
Victory.
Victory.
Yeah.
How are you,
Can you
sir?
hear us? Yes.
Hi,
Good.
Shunyun.
Good. Good. How are you?
Good, good. So I'm just trying to arrange my screen. I have too many
Okay.
things
Sure.
open.
Sure. Sure. I
I'm
was
just
just
gonna
catching up with
share.
Herman
Oh,
your
okay.
yesterday meeting. Yeah. Okay.
Yeah. Um. So I made some changes at per the meeting we had
Okay.
yesterday.
Okay. All right. Let me just
Um.
have a look.
Okay, I'm not sure if I should show you both. Okay, let me show you this first. Delete that. So basically started with a centralized region. I sort of like
Okay.
this picture a bit because it sort of simplifies things, and we can sort of picture these nodes. I mean, these connectors, or should I say, these lines, the straight lines, as some form of Voronoi partitioning,
Mm-hmm.
such that
Okay.
all these nodes are connected to that matcher. So the yellow, the one marked in yellow at the center, we can think of that as a matcher, and we can think of this as a centralized setup
Okay.
where
Yes.
all the nodes in that region are connected to one matcher. Right. So in the centralized, you can ignore this picture. Uh, again, this data structure, it keeps changing. That's why I'm sort of leaving it like this. But in the future, I'm going to put this in a table to sort of explain that properly.
Okay.
But it's simple. We have the ID, we have the address, the basics, and then the publisher channels. So this is for publisher now, or should I say
Okay.
the matcher? Let me say matcher. I think matcher might be more appropriate. But for now, let me just call it. And subscribed node list. So what are the nodes that are subscribed in that region? This is now the server, sort of performing the role of a server. And if you notice here, I sort of made this publisher identity, right? Where it contains both the
Okay.
ID and the address, just to keep things simple. So first, start. So create the node table. The idea is to first sort of structure the data. You have the identity, the publish channel list, right? The publish area, the subscribe node list. So this basically just gives us what are the nodes in the region that are subscribed to that matcher, and maybe
Okay.
some form of payload that needs to be sent if required. Um, so step one after that is to broadcast the P identity to that region. Let's call it the Wi-Fi, for example, where you're sending in, this is my network, this is my ID, and then we're waiting for connection requests. So if the publisher gets a node, a subscription request, what happens? It first scans the. Is this the right document? Yes. It scans the subscribe table, right? Which is where. What am I? Sorry, I think I forgot to put the drawing there, but it basically checks the channel list, the channel table, and then sees if sorry, I think I'm confusing things here. Sorry, hold on. So if the publisher gets a sub request, right, from a node, which is the request here, if it gets that request, it checks its table. It sort of checks the channel list to see. I think this should be PHCH list. Sorry, it's supposed to check the list and then see if it has the the channel it's looking for, the subscriber is looking for. If it contains the request, then send success message, right? Just like a simple boolean would do there, and say, then this publisher would add the identity to the subscribe node list. And if you look at that, that's what subscribe node list looks like. The identity of the subscriber, its area, and its channel list, or what it's trying to subscribe to, the channel is trying to subscribe to. And then once the subscribe is successful, send a message as well to say you've been subscribed. Then send the PID, the publisher identity to sub. So once it's subscribed and it's successful, then also the idea is it wants to send the identity of the publisher to just keep the subscriber updated that this is who you're subscribed to. Although now, come to think of it, I think this already sort of happens here where there's a connection request, but that's no problem. So now once this is the subscriber now, for the subscriber node, it has an ID, it has an address, it has all this information. And in this category, if you notice,
sorry, just quickly. So what you just described, what node is it? What is the functions here? Is that the matcher or the publisher?
The it's the publisher, but I'm just using the matcher as both matcher and publisher.
Okay, all right. So you're talking about matcher / publisher.
/ publisher, yeah.
Okay.
So
all
there's
right.
bit of
both.
Okay. Yeah. And then subscriber data type is similar. What you want to subscribe to, what's its subscribe area. It can be, if you notice this, I basically use X1. This is basically, I put it on an XY plane to sort of illustrate the, coordinate on an XY plane. So it's going to be like a square. This could change in the future to maybe a circle or a polygon, but for now, and then sub detail, the channel list. So I put 10 here as a boolean to sort of say, is it subscribed or is it not subscribed? And then the identity of the publisher or the matcher. And also subscriber identity. I put this here just as a reference because it's going to be required later. So subscriber joins the network. There's the node table for the subscriber as well. This is what the subscriber table will look like. You have the identity, also quite similar to that. It's channels. It wants to subscribe to the area, the detail, like what it's subscribed to, and if it's subscribed or not subscribed, and its identity. Sorry, what am I doing? And payload. And the publisher identity. Sorry. So all of that comes in the S detail, and the idea is I want to send my identity to server that that's my IP and the address. And so once subscriber receives that, you want to check the area that, okay, my subscriber, am I in the region? The subscriber region, is it the same as the publisher region? And if it's true, then I want to send subscription request. Now I created this after, because I actually think this also sort of comes in later down the road in the decentralized setup. So send subscription request with the identity, with the area, and with the channel list. So the channels, I think I might need to come up with a better word here, but the identity, the area, its area, the subscription area or its current area, and its subscription list. And if the subscription is successful, which is what that happens there. Yeah, wait for success message, update detail with status and identity. I mean, a publisher identity. So if it was successful, the idea is you want to create a sort of a new table. That's or For now it's going to be a new table, but I'm thinking it might actually be better if it's all updating the same table. But for simplicity's sake, I'm just going to say create new table with subscriber identity, right? What's the channel list, the area, the detail. So what am I doing? So this is mostly what changes here. This is what is added to the system, which is if it's on or off. I mean, if it's subscribed or not, and if it is subscribed, what is the identity of the publisher it's currently subscribed to, and receive previous messages from channel. That's where the payload information comes in, and stand by for new messages. Else, just time out the error and go to step one. Now for this decentralized setup, it sort of gets a bit complicated. Not complicated, but I think I might have complicated things a little bit. So I sort of drew this. I don't know if you can see this very well. If I should zoom in a bit. So the idea is we have that, there's like a centralized setup, but in a distributed environment. So in this case, C1 does not know about C4, but C1 knows about C2 and C3. Sorry, I didn't type that. I don't know if that makes sense, but and A is supposed to suggest this is like a subscription area now. Area it wants to subscribe to, or A2, A3, A4. So I deliberately put this in because this is like a rare, not rare, but if there's a case where this area is sort of close to this, or it's also sort of close to that, and how does the system decide if I want to go from C1 to subscribe to this region, which one works best? But I think in the future that would basically be the shortest distance. Which one is closest to? Which matcher is closest to A4, basically. So yeah, if you can see, C1 is they share, the matcher here knows about the matcher in A2. The matcher in A1 also knows about the matcher in A3, right? And this is C3. This is C3, C4. I mean C2, C3. Right? And if I go back to our picture here, again, you can ignore this picture, but so the idea now is to sort of make each I think matcher, I meant to write matcher yet, not manager. We call them matchers, or maybe I should call them managers. That might sound better. But when the pub request is made, for example, the idea is to sort of repeat the process, the PPF process, which is what I call the publisher process flow process. So it's the same thing it does, but on a distributed scale. You can still see my screen, right? Yeah. I think I'm sharing the full screen. So the publisher request that each node makes to the matcher here, the idea is this matcher should also make the same request to the nodes around it, right? But in this case, we gave it a new ID. So each matcher has its own ID. Each matcher has its own address. So it's sort of the same definition if you look at all of this, but the difference is MID, for example, if it was just ID or SID, subscriber channel list, matcher subscription area, and basically it's to repeat the same process. Now, if you look at now again, I think I got caught in my own thoughts, but let me just try to create data table, the same, similar. You will have the matcher ID, the matcher channel list. So the idea is all the channels that are subscribed to it, the matcher area or the matcher region, the matcher subscription details, and the sub details. I don't know if it's here. Okay, sorry. The sub detail, that's where this sort of comes in, the channel list as well as the subscription statuses. for all the channels there. The NM detail, yeah, neighbor matcher detail. So the neighbors and their information. So again, I think I have to go into more detail again as to define how the neighbors will be defined and how their ports and ID will be, how it will be structured rather. And then the request, S request. So this is what the request is. So if we have a node in area 1, or so let me say C1, sorry, one of these nodes here wants to subscribe to A3 region. It wants to subscribe to A3 region. It first goes through the matcher. It performs the normal process. When the matcher does not have the information, then it forwards the request to the neighbors, and it basically repeats the request until it finds this, and then this matcher here performs the subscribe routine. Okay, maybe I should call them routines, and that's why I sort of called the sub process. Sorry, I'm going too long now. But again, this is now where I think I'm sort of complicating things so much. I don't know. Maybe it's because I've not put in the data tables properly. But it's
Okay.
a simple. It's sorry.
So Victor, just go back to the previous image you showed,
Yeah.
the one where you had the areas to which you subscribe. Yes. Okay.
This one, yeah. Okay.
Yeah, that's fine. That's fine. So there's a couple of comments that I just have over here. So I see you've got a Voronoi diagram over there. It looks like it. Okay. So you've got.
Yeah.
So I mean, we spoke yesterday that the green nodes are basically the matchers, and that they basically will form part of a Voronoi diagram, and that the Voronoi area or the Voronoi cell is basically the whole area which is under the control of that specific matcher, or let's call it the responsibility of that matcher. Okay.
Yes.
Okay. So when you talk about C1, okay. So one comment I have is, so this matcher is responsible not for the rectangle C1, but it's responsible for the polygon, which is that Voronoi cell.
Well, I think it's responsible for both. So maybe I should have. You can think of C1 as, the green. Let's how do I put it? Let me picture it like this. Is how I pictured it. In C1, all these nodes are connected to the matcher.
Okay, so in other words,
through a Voronoi sort of structure as well. So
it's not necessary to do it. I mean, it's not necessary to do that if you assume that. So if we say C1 is just a cluster of nodes that are directly connected to the matcher, you don't need a secondary Voronoi diagram. Yeah. Okay. So that's the first comment I want to make. Yeah. Okay. So there's only one you only need one partitioning of your publication or your spatial environment for this to work. The second thing is that if you have 5, you must have the same number of matchers than the number of Voronoi cells. So for instance, this A4 area over here, that's fine to have another Voronoi cell over there, but then you need another matcher in that area, because the locations of the matchers basically determines the Voronoi diagram, which basically determines the number of Voronoi cells there are in the area. So that's a minor point, but so there should be a matcher there as well. Okay. And I think yesterday we said the assumption is that the matchers are somehow connected to their neighbors in the Voronoi region, and then so the green nodes are connected to their neighbors, and that the blue nodes are basically publishers or subscribers that are directly connected to the matcher in their region. Is that correct?
Yeah, exactly.
Okay. So So one question I have is you're talking about the public. You've got, I think you called it a publication request. Is that a node publishing a message, or is that a node somehow requesting information?
So the publication request is basically publishing information
A
or
message.
publishing data. Yeah, a message, and the subscriber is requesting a message from the publishers. Basically requesting the
So
message from the publisher, but then the publisher has the channels in terms of the. So it's not like a direct connection per se. It's basically
okay,
publishing to a certain channel list.
okay. But remember the assumption is that the publishers and the subscribers never have to know each other's identity. It's not necessary. You never need to request a list of the publishers, and the only things which need to know what the list of subscribers are actually the matchers, and they only
Okay.
need to know the subscribers of areas in their region or in their Voronoi cell.
That's my first
Oh,
feedback as well.
okay. So
Victory,
it means
yes,
sorry.
go ahead,
So
go ahead.
basically it means, for example, this whole process, there has to be a process flow for both the publisher, the subscriber, and the matcher.
Well, kind of, but actually, Matcher just interact with the publisher and subscribers, right?
Yeah.
You see?
Okay.
Basically, it's kind of like the published. Well, there's a reason why it's called a matcher. Okay, you can think of it as a broker. Well, in PubSub they call it the broker, right?
Yeah.
So it's actually the entity that shields publishers away from subscribers, so that they
Okay.
never have to know about each other's existence ever.
Okay.
See?
Okay.
Okay. So when you're designing data structure or thinking about the message exchange protocol, always keep that in mind.
Okay.
Okay.
So just to
So-
confirm
so-
then.
And you can
perhaps
simplify a lot, actually.
Yeah.
So perhaps I think that the reason why we don't want publishers and subscribers to know their identities is, let's say I want to publish a message, right? And I want it to reach one other person or a million other persons, right? So
Yeah.
if I need to publish to if my system is such that I need to know the identity of my subscribers, then somehow each time a subscriber is added or or is removed, then somehow that information needs to reach the publisher, right? And that's just not a scalable system. So
Yes, Victory. Yes.
Yeah.
One very easy way to picture this is think of Twitter. Twitter is
Yeah.
exactly a PubSub system.
Yeah.
Okay. If you think about, just say if you publish, let's say someone famous, Richard Branson, or Elon Musk, right? He tweets a lot. A lot
Yeah.
of people are following him. But
Yeah.
Musk doesn't know and doesn't have to know, like who are the subscribers,
Yeah.
right? Twitter does.
Yeah.
But not
yeah.
Elon Musk, not his notebook,
this
not
case-
his computer, not his cell phone, right?
Twitter is the what's the word? Matcher? Or Twitter engine?
Twitter is the matcher. That's completely correct.
Twitter
yeah.
is the matcher. Twitter is the
Yeah.
matcher. It is a PubSub system.
Yeah. Okay. Okay.
Okay.
Okay. Okay.
Okay,
Wow.
so
okay,
that's the
see.
first feedback.
see.
You're
Wow.
getting that now, right? Okay.
I see. Yeah.
So if you understand this, then try to review, your message format and protocol.
Yeah.
Okay, and
yeah.
you can see that you might be able to eliminate a lot of things.
Yeah.
Okay.
Especially the data structure.
Right, exactly. All right, and then there's the second part. There's one feedback is actually more of curiosity. I think you have the channels, right? The channels in here. Why? How do they work, and why do you have the channels?
So the idea is the publisher has just let me see if I can find this quickly. Crap. Okay, I don't have it open. Let me just look for. The thing is, I did create. Sorry. Let me. There's a picture I wanted to. I want to just show quickly. For. I think it's this one. I hope. There's the idea is each let me see, I hope it's here. Yeah, there's something like that. I don't know if you, so the idea behind the channel list is the publisher has so all these arrows are supposed to suggest the channel list. So channel temperature, for example, or channel let me see.
Different kinds of data types, right? Different data.
Exactly.
Types.
Yeah.
Okay.
So the idea is this is a publisher, and there's a channel list, and this channel list is some form of array that has all these things or all these data channels it publishes to. Right. So when the subscriber makes a request, it makes a request and it sees everything, or it sees all this as a list of channels. So I'm guessing there are times where maybe a publisher publishes to 3 different channels, and the subscriber just wants to subscribe to the one, and not necessarily all 3.
So one feedback I can give you is that just in the same way that the subscriber doesn't need to know the identity of the publisher, you don't actually the subscriber. I mean, conceptually, the subscriber doesn't also need to know what all the channels are that is available. You could conceivably have a system which says, I'm a subscriber. I'm going to preemptively say that I want to receive temperature messages or messages which is published on the temperature channel in this area. And then 5 days go past, and then a publisher comes around in that region and it publishes a message on the temperature channel in that region. And then the matcher would have said, oh, here is a message on the temperature channel, and there is a subscriber to that channel. So now I'm going to forward it. So the subscriber doesn't first have to receive a list of channels. It just says,
okay,
there's a channel.
Give me.
And the matcher just says, okay, well,
okay,
this is a channel. I don't have this channel before, so I'm going to add it, as one of the criteria that I need to match when I figure out who the recipients are of a specific publication.
Okay. All right.
Okay.
One. Yes. Is that understood?
Yes. So
okay. All right.
Basically, all the work goes. I mean, all the should I say the core engine, is what's the word? The matcher basically runs the whole system. Or should I say the matcher?
Exactly.
Oh,
Yes.
Okay.
Yep. And there's one more thing. So just to clarify, so does the channel in what you're thinking about, does it work only after areas are being matched?
Not necessarily. I mean, that was
or not necessarily.
Yeah, that was not. I think what I had in
Okay.
mind was the publisher has some of this information stored somehow.
Okay.
And the idea is if there's a matcher or a subscriber that comes around maybe 3 days after it sent the message, it basically first receives the previous messages.
So just to clarify, it doesn't have to work alongside or necessarily require an area to subscribe and publish. Is that what you're thinking?
Oh, you mean the publishing region now?
Yes. Okay. No. Okay. Yes. The publish or subscribe area. Okay. I guess what I'm trying to get at is this. In the traditional, existing PubSub system, there is just the concept of channel. Okay, so you can subscribe to a channel A and publish to a channel A. Okay, and you get stuff, right? But in spatial PubSub, okay, I think the simplest form is that the areas are the channels. You see?
Oh,
Okay.
okay.
So what I guess what I'm suggesting is you don't have to have the concept of channels in
Okay.
a very simple vanilla spatial PubSub. However,
Okay.
you can add additional concepts like temperatures or like whatever sensors, right, that are sensing, and
Yeah.
that can be done through something else. Okay, but just to sort of distinguish, to avoid confusion, I would suggest use a different term. And in my previous work, I used the term layer. Okay, layer,
Layer. Okay.
right, to separate. But obviously, you can have something else as well. Just I mean, the whole idea is that it's something that works after the areas are matched. You see,
Okay.
so the layer, I mean, it kind of always go along with a. For example, you can subscribe to an area, right? And you
Yeah.
can optionally indicate your layer as, for
Okay.
example, the temperature layer, right?
Yeah.
Or the
Yeah.
frequency
Yeah.
layer or whatever layer, okay? But
Okay.
it's not required, you see?
Okay.
It's
Okay.
kind of like
So
an optional parameter, okay? And it
I see.
only happens after the areas are being matched. So
Okay.
this distinguish it from, from the channel-based PubSub. Okay.
Okay. Layers.
I mean, the terminologies is something obviously, I mean, you can call it different things, but
Okay.
I guess the important thing is this concept that
Okay.
whether the channel you're talking about is working within areas, after they are being matched, or it's independent from the areas, as in the traditional PubSub. I think that is also a very important distinction. You
Okay.
see,
Okay. That's what
and
you mean.
okay, and I'd like to mention, okay, I think it's fine in a practical system that you have both spatial PubSub and channel-based PubSub. I think it's perfectly fine. Okay.
Yeah.
However, conceptually, they are different, and they are and should be different systems or managed independently.
Okay.
Okay, that does that make sense?
Yeah. Yeah.
And even if you're supporting channel-based PubSub on top of like a Voronoi, like a VOM layer, okay, there
Yeah.
are ways to do that. Okay, there are ways to do that to sort of, but uh, I would consider that as a separate system. Okay, from the basic spatial PubSub system. Okay, so
Yeah.
I would suggest and recommend to concentrate on the spatial PubSub part first. Okay,
Okay.
and I guess just for the time being, not to worry about supporting channel-based PubSub
Yeah.
for the moment.
Okay.
Yes,
That does that make
because
sense?
it's easy to add the channel after you sorted out
Exactly,
Mm.
the spatial
exactly.
part.
Once you have a working spatial PubSub system, okay,
Then
actually you can
create
imagine
layers.
channel base as simply a subscription to the whole area, okay, of the
Mm,
system,
Mm.
and the
Yeah.
mm,
publication is just publishing to the whole area of the system. That will give you exactly the same effect as a channel-based PubSub. You see?
Okay. Yeah.
Okay, but
Yep.
I would first recommend to maybe use a different term. Okay, I used layer, but obviously you can find pick something you
Okay.
like. Okay,
Okay.
but my suggestion is to have a separate term from channel, because
Mm.
channel is kind of already being widely used in
Okay.
the channel-based PubSub. You know,
Okay.
does that make sense?
Yeah. Yeah. Um, so it can be like the basically there's like that underlying layer that does the matching and the subscription to
Right, right.
establish communication.
Right. I mean, and also one important distinction I was trying to I was trying to convey is it's only after the areas are being matched. Okay.
Okay.
And only then does the layer come into play.
All right.
Okay.
All right.
As in, like, I want to subscribe only for temperature data, or I want to only get like vibration, right? Or
Okay.
you see.
So those are like stuff that can sort of be created depending on the application then.
Exactly.
Okay. Okay.
And also, as a system design, you don't have to like design a temperature because that's application specific. For the system's concern, it could
Yeah.
just be like a number. It's just like a number,
Okay. Okay.
or like a type. Or like a type. It can be a called layer, called type, or called something else. Yeah.
Okay.
Okay. Does that make
I see what
sense?
you mean. Yeah.
Okay. All right. So Victor, I think if you get all these, if all this is understood, I'm pretty sure you can revise the design, and in
Yeah.
fact simplify it a lot. Okay.
It's gonna be simplified significantly because
Right.
it looks like publisher and subscribers doing way too much.
And don't worry about like pure channel based PubSub for now.
Yes. Yeah.
Focus on the spatial PubSub part.
Yeah.
Okay.
Okay.
Okay. We'll do so.
All right. Okay.
Cool.
All right.
Thank
So
you. Thank
hope
you
that's
very
been
much, sir.
helpful. And yeah.
Very.
So
I saw
well.
there was a link Professor Herman shared on
Yes,
Slack.
I
check it
sent
out.
you a tutorial on the publish subscribe. How it works basically, because it might help you understanding the basic assumption of the spatial PubSub.
All right.
Cool. Okay.
Okay. All right.
Thanks.
So talk Tuesday then. All right. Okay.
Yes.
Yep.
Thank you very much,
week.
sir.
All right. Okay.
Yeah,
Yeah.
cheers.
Take care.
Bye.
Enjoy your
Bye-bye.
weekend.
Bye-bye. You too. Bye-bye.